In this video, I want to introduce the idea of solving a system of equations and to explain what the solution of a system of equations looks like on a graph. Then in the next couple of videos, we'll look at some algebraic ways to solve systems of equations. But I want us to understand what is going on when we're looking for a solution. So the solutions of a system of equations are the values of the variables that make all the equations true. Graphically speaking, these solutions are the points of intersection of the graphs. So for example, if I want to solve this system of equations, I have two equations here. They're both equations of lines. We're going to stick to solving systems of linear equations here. I could graph those lines. Here's a sketch of the graph of those lines. The solution that I'm looking for, the x and y value that I'm looking for when I search for values that make both of these equations true, correspond to this point of intersection of the graphs. These lines cross in exactly one place. That x and y value is 1, -1. And that is the solution to this system of equations. If I plug in 1 for x and -1 for y, both of these equations will be true or consistent. So the solutions are the same as the point of intersection of the graphs. That means that there are three different options when we're solving systems of linear equations. Let's look at the types of solutions that we could see from systems of linear equations. So if we're talking about solving systems of two linear equations, which is what we'll stick to in this course, we have several different scenarios when it comes to the graphs of those equations. First, we could have what are called independent equations. These are two different lines that intersect each other. And if lines intersect, they intersect in only one point. That intersection is the solution. So for independent equations, there is one solution. It has an x value and a y value, but it's one unique solution. However, we could also have what are called inconsistent equations. These represent lines that are parallel to each other. Remember, those lines have the same slope and they never intersect. They never intersect, so there are no solutions to these equations. If we're solving this algebraically, we would recognize inconsistent equations by reaching a contradiction, an equation that says something like 1 = 2 or 4 = 5. At that point, we can stop and say there are no solutions to that system of equations. There's a third option. The equations could be dependent equations. And that happens when one equation is actually a copy of the other one. It's maybe a multiple of the other line. And they actually are the same line when you graph them on an xy plane. Dependent equations have infinite solutions because they represent the same line. So every x, y point on this line, of which there are infinitely many points, will solve the system of equations because the equations are just a copy of one another. You'll recognize this scenario as you solve algebraically when you arrive at equations that are always true, like 5 = 5 or 0 = 0. Then you can stop and say there are infinite solutions to that system of equations.